Chapter 1 slides from Dennis Wixom and Tegarden, System Analysis and Design with UML. Chapter 1 is Introduction to System Analysis and Design. I'm not going to read through everything. You can read as well as I can read, so probably better. The top points here is this is an overview. We're talking about the systems development lifecycle, or the software development lifecycle, the SDLC. We talk about how a team works in the SDLC. We'll talk about object-orientedness, and we'll talk about UML, the Unified Modeling Language. So why do we need a formal process? Well, because people make mistakes. And having a formal process tries to avoid some of those mistakes. The system analyst is the person who's the key to setting up the system for success. So you need to do it lots, and you need to have seen lots, both good things and problem things. But it's a very specific task. So here's the life cycle, and it's continuous. So say we start with planning, then we've got analysis, design, and implementation. And then for the next version, we go back to planning again. And any way of working with software has these four elements, regardless of whether it's traditional project management or agile or any of the other possible ways to do it. I'm not going to read through that. So planning is about why should we build the system, what's the value, and how long will it take. Analysis is now starting to get into who will use it, what should the system do, and when and where will it be used. Design phase is how do we build it. Okay. And then in the planning phase, we initiate, we do project management. In the analysis phase, we develop a strategy, we gather requirements, we develop a proposal. In the design phase, we design, we find the architecture and the interfaces. Some people believe that the interfaces, controlling the interfaces, are the key thing that you need to do when you're building a system. We need to talk about databases, and then we need to figure out exactly what work we need to do in the design phase. And then the implementation is constructing it, testing it, installing it, and supporting it. There's lots of ways to approach the SDLC. Various possible categories are process-oriented, data-centered, object-oriented, structured, rapid action development, or agile development. The structured ones are waterfall and parallel. Rapid, we could use phased or prototyping. And agile, the two main ones are extreme and scrum. And they all have their pluses and minuses, right? This table would have you believe that Scrum is good to excellent for everything. The key piece that I would take away from this is about unclear user requirements. In general, the traditional approach, the waterfall approach, is not clear, was not good at dealing with unclear user requirements. So that's partly why the agile methodologies were developed. And there's some of the skills that an analyst might need. And there's different roles: business analyst, system analyst, infrastructure analyst, change management analyst, and the project manager. What we're going to look at in this course is object-oriented systems analysis and design, right? So we want to turn the solution we're coming up with into code And most of the languages we're going to think about using are object-oriented languages. So it's good to start thinking in that way early. And a good way to help with that without actually writing code is to use UML. And the particular pieces of object-oriented analysis and design are that we're use case driven. We're very keen on making the architecture central to what we're doing, but we do things in an iterative and incremental way. So we don't just design everything and then build everything. We maybe design the first pieces, and then we put that in place, and then we have another think about how things hang together. So the key pieces of object-oriented systems is we use classes and objects, and we use methods and messages. And you've probably already done lots of programming courses about object-orientedness. But we're going to talk about it from a slightly more abstract viewpoint. Another couple of key pieces: we want to encapsulate and hide information, and we want to inherit behavior sometimes. Not always, but sometimes. And then sometimes it's good to have what's called polymorphism and dynamic binding. This is where we define an interface that has the same messages regardless of what the actual hardware is doing. But we can change what the hardware is without having to change the software. We might have to have a slightly different driver or what have you, but the key thing is the main software using the utility doesn't have to change what it does. It just needs to know that this thing allows interactions with it through this interface. So one of the early things we're going to talk about is use cases, and I'm not going to talk about them now, but we will very shortly in the course. And architecture. How do we decide on an architecture? And I've already talked briefly about those. I'm not going to go into any detail. So quite a while ago, there was a process come up with called the unified process. And it was a way of working with software in the different phases of software. And it showed you the sorts of UML techniques you needed to use in each aspect of the project. And the key piece is this diagram here, where the engineering workflows of business modeling, requirements analysis, design, implementation, test, and deployment, with the appropriate level of work in each of those, as you can see in the graph. And then there's supporting workflows in terms of configuration management, project management, and the environment. And you can see not all of these things happen all throughout the project. For example, the requirements has a peak relatively early on in elaboration, as does analysis. But the deployment doesn't happen until towards the end, when we're transitioning from the development team to the customer. And I'm not going to go through the different phases. You can read about them, or the different workflows, right? The things I want to talk about next are UML, and there are several different diagrams. It looks like version 2.5 has 15. I'm not going to get you to necessarily use all different sorts of UML diagrams, but we'll certainly use some. The structure diagrams let us represent how classes interact, how instances of classes or objects interact, how the packages within a system interact, how the deployment of a system works, the different components in a deployment, and how things are composed. Then there's other sorts of diagrams called behavioral rather than structural diagrams. And these show the dynamic relationships between either the instances or the objects and how they communicate. And these are activity diagrams, sequence diagrams, communication, interaction, timing, state machines of protocol and behavior types, and use case diagrams. Quick summary. Part of this course is about the system development lifecycle and how we tackle that from an object-oriented analysis and design viewpoint using UML. And that's about all I have to say about Chapter 1. Thank you for your time.